Hmm, 340 meters ng fence. Paano ko kaya itong mga gamit to the max? Kailangan ko ng magaling na architect para sa project na to.
Surprise! Project baka mo? Eto na ako. Start na natin yung bidding.
Sara Diskaya? Hindi ba nakulong ka na?
Ang OA naman ito. Hindi naman talaga ako corrupt, no? Medyo lang. Anyways, ako yung magpapaganda sa garden mo.
The objective of this project was to design a rectangular garden with the maximum possible area using a fixed amount of fencing, which for the client is 340 meters. Since the garden is built beside the house, only 3 sides of the garden need fencing, while the house serves as the 4th side.
We define W as the width of the garden perpendicular to the house and L as the length parallel to the house. Based on the fencing condition, we form the equation 2W plus L is equal to 340, which mathematically represents the limitation on fencing materials.
Solving this equation for L gives L is equals to 340 minus 2W. To determine the maximum area, we took the derivative of the area function. The derivative is A prime is equals to 340 minus 4W. Setting the derivative equal to 0 and solving gives W is equals to 85 meters. Substituting this value back into the mathematical model yields area is equals to 14,450 square meters. To verify that this critical point corresponds to a maximum and not a minimum, we applied the second order derivative test. Taking the second derivative gives the second derivative of A, which is negative 4. Since the second derivative is negative, the area function is concave downward, confirming that W is equals to 85 meters produces a maximum area. Substituting this value back into the fencing equation gives length is equals to 170 meters. Therefore, we determined that the optimal dimensions of the garden are 85 meters in width, 170 meters in length, producing a maximum area of 14,450 square meters. These calculus-derived measurements were then transformed into a digital model using a scale of 1 Bloxburg tile equals 5 meters. Applying this scale, the garden was constructed with a width of 17 tiles and a length of 34 tiles, accurately reflecting the optimized dimensions.
Grabe, parang ayoko nang bumalik sa loob ng bahay. Pwede bang dito na lang ako tumira?
Pwede naman. Additional charge nga lang for sustainable living fee.
Everything you see here was carefully designed, using calculus, not vibes.
Ang satisfying naman ng walkway.
The garden features a multi-purpose pathway system that clearly divides zones. These stone and wood paths improve accessibility, prevent soil compaction, and encourage community use, aligning with SDG 11, Sustainable Cities and Communities.
At kung may drama ka sa buhay, may path ka pa ring susundan.
Para saan naman tong drum na to?
The garden includes a rainwater harvesting system. Rainwater collected from the house roof is stored and reused for irrigation, reducing freshwater consumption, and supporting SDG 6, clean water and sanitation.
Libre tubig, walang resibo, walang tanong.
Pwede ko ba tong anihan?
Yes, the edible garden zones include vegetable beds, a herb near the garden house, and vertical planters. This supports household food security and reflects SDG 2, Zero Hunger.
Oh, pag nagtaas presyo ng groceries, may backup plan ka na.
Uy, may sign pa. Pollinator zone?
The pollinator strip uses native flowering plants to support bees and butterflies, helping maintain biodiversity under SDG 15, Life on Land.
May rules dito, bawal mang spray ng chismis.
Lastly, the garden uses solar-powered lighting and small solar panels near the house.
reducing electricity consumption while maintaining safety. This now supports SDG 7, affordable and clean energy.
Ganda ng garden ah. Patingin naman ako ng bahay. Oh, ano to? Ba't walang laman yung loob? Ginos project mo ba yung bahay ko?